Hey everybody, happy to see you here. So this talk was originally and is still listed as Web and Android United, Kotlin-Powered cross-platform excellence, right? And I admit, I applied, it got picked up, I was super happy, I stared at the title a little bit, and after a while I realized I made a terrible mistake. At least I felt like I had, so I changed it up a little bit. And I called it this Kotlin Cross Grooves, cross-platform beats. So why did I decide to go with a theme like that? Well, it's late, we're Friday. I figured let's do something a bit more lightweight. We might not want to see 1,000 slides of code and things like that. So the PSA for today for this talk is that we're talking more about strategies and ideas and approaches to writing Kotlin multi-platform code in a way that you don't get painted into a corner and you can reuse it on very different platforms. My focus here today is the web and Android and a little bit of backend. But again, not going to explain to you how to set up MySQL, not going to explain any of the technical details. We're more going with the philosophy of trying to write as little code as possible and reusing as much of our logic as we can. All right, so before I get into any further details, there's this big mugshot of me right there. I'm Etienne Caron. I'm an Android software developer. I've been doing software development since good old 1997. Back-end work right up until the 2010s, where I switched to mobile development, and here I am. So mobile space, I have a fair amount of experience. I've worked for companies like Nuance, Intel, McAfee in the security space, Shopify, which is another well-known name. I went independent a few years ago, and some of my more recent customers include companies like Bell Canada and Instacart, most recently. So a big thank you to the DroidCon org, to everybody here, also to the Google Developer Expert Program for sponsoring my trip and my stay. So everybody's help and the support of the community is always super appreciated. So I just wanted to take a second to say this out loud. Right, so what are we talking about today? Well, to the story that I decided to sort of pick to carry a little bit of the ideas I wanted to share, we're talking a bit about the DJ scene and record collecting more specifically. The reason I've been collecting 12-inch records is I've always been fascinated by the world of scratch DJs and hip-hop DJs. Since I discovered that genre, I have to say, a bit late in the 90s, personally. So back then, I got myself a turntable, and I got into it as a hobby. It's a hobby, so that's the reason the sound is not connected, because I don't want to subject you to what this actually sounds like. But what happened is that I got into this, I got the turntables, I was like, all right, this is fun, and then, I started collecting records over the years. That was the original setup pretty much, and then it sort of slowly morphed into a bit more records, and a bit of an unhealthy sort of hoarding habit. So disclaimer, this is not actually my house. This is very close to what my house looks like right now, but this is a cafe in Montreal that actually gives DJ courses and has also a monstrous collection of vinyl. The last time I checked, though, quite honestly, I think I almost have that many. So you might be wondering, how does someone actually end up with that many records, right? What the heck happened there? And then the second question might be, why? Well, I explained my passion with it, but the how and the why are kind of tangential questions, really. My real existential question right now today is, how do I get rid of at least half of that amount of records? So the core of the talk is about building software, and let's pretend that the sane answer to getting rid of all those records is to start a record store. Right? So a side gig, very ambitious one, but I've heard from people in the know that it's kind of easy nowadays to start an online store with all sorts of nice technologies. I've worked at one of those two places. I know that they both do actually excellent software work. I think we all kind of know about this. You can also sell a lot of stuff in what are called pop-up shops or in swap meets like these. So that's like I visited with my daughter in yellow the Netherlands this winter. That's where her family, the family of her mom is from. And this right there is actually a swap meet for records. It's like the biggest one in the Netherlands. And I discovered that other people had the same kind of hoarding problems that I did at that point last winter. I also heard that some people actually managed to build pretty decent businesses out of selling records out of the back of their car. So that's the reasoning behind all this. Now, if you want to sell records, the very minimum for any kind of e-commerce shop, you need two things. You need to be able to manage your product catalog and inventory, which are closely related things, and you need to be able to take orders and payments. And I'm skipping over a whole lot of other steps, but those are the two big ones. And today we're really going to focus on the bigger problem in my life presently, which is the inventory to actually know, what's my collection like. So spoilers, we'll just defer all the order and payments to these two, right? And we won't dig into that very much, quite honestly. All right, so the inventory is the problem I really want to solve. So when you want to catalog thousands of records, it's actually a pretty niche requirement, and it made sense to me to try and develop a bit my own sort of software solution to sort through all of these things, start basically knowing what I had in my collection, how much it was worth, if other people were interested, eventually maybe trading with people that are interested in all of that, and so forth. So going through all those record boxes and bins, I need to create at the very least a product catalog entry for each new kind of record I find. And surprisingly enough, there's not that many doubles in the thousands of records I managed to find and collect over the years. So that's a bit of a challenge, but we'll get back to that in a second. So if you think of products like an album as an album from an artist, that's kind of simple, but reality is really not that nice and simple. So here we see different types of records. Like we can see that there's different types of pressing, which is actually quite important, the quality of the records. So back in the day, if you bought like really cheap disco records, you would take them in your hands and you would go like this, and they would go like whoa, 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 whoa. They would wobble. And those are actually very cheap. You put them on a turntable, and sometimes they're so cheap that the needle sort of skids off of the record. It's kind of odd. Really good quality records have deeper grooves and are a bit more heavy. So the one at the bottom right, the Paul's Boutique one from the Beastie Boys, if you know, that one's like 180-gram collector edition. So that one, the quality of the sound is going to be better than some of the original prints. And that was released like in the 2010s or something. The purple vinyl over there is more like, oh, gee, that's nice. Sometimes even those colored vinyls actually play a little bit worse because the material is not the same. Long story short, for any one given product, we can have a lot of variance effectively. So what we need to start thinking about is a bit more of a way of not only building the catalog, but building different types of variants so that we can have an inventory that actually makes some sense. The other thing, too, that we need to think about is that we're dealing with used records, right? So even if I have multiple copies of the same release, we might not be able to slot them as the same thing in the same instance in our database. We could have like a really crappy, warped copy of one record and then a perfectly pristine copy of the same release, same year, same everything. So we can't actually just bin those in the same place and sell them at the same price, right? All right, so skipping a little bit ahead, because this is not going to be about data building all that much. This is the kind of schema that you would get from one of the big major e-commerce providers. So I've sort of hinted at the idea that there's a product, which is like this more generic idea of the thing you're selling, options that you could sort of tweak on the product. So if we were talking about t-shirts, options would be size and color. I gave you a hint as to what kind of options we have for records. Variant is the actual thing that we're tracking an inventory of and we're actually selling. Inventory is kind of self-explanatory. It's like an amount of the variant that we have in store. And the location, we won't talk about it too much, but it's interesting to know about these. Your record is actually in an inventory somewhere, right? Like your product is somewhere in a specific place. And if you have multiple stores, that's a thing. If you would sell from different stores, you need to know where the record is. But if we start thinking about, oh, I want to sell this at pop-up shops or at flea markets, Then you might have an inventory that you consider your point of sale inventory, and if the rest of your record collection is being sold online, you sort of need to account for it differently, so that if somebody goes into the website and buys a copy of the record, it's not actually being sold at the flea market that day, or something like that. Right, yeah, the simplified diagram at this point, though, because I don't want to deal with like a whole lot of different entities and don't want to, muddle our thinking today, we can just think of product variants as a thing. And if we are ourselves building our own little inventory system, we can simplify the inventory system and just, reconciliate with the big e-commerce ones later on once we're just going to hook up to them. But again, not that much code today. It's more like concepts, right, that we're talking about. All right. So the first stage of things is I would like to take an inventory with my smartphone app. Okay, what would that look like under the hood? We have a very simple concept of a repository here, right? We want to do the usual CRUD, the create, read, and update and delete of our product variants and our little records. So, this could be backed by any kind of different interface, right? The different things that we know about are on Android is SQLite, Realm potentially, or Firebase. Everybody's also used the REST backend with the different libraries that we have available. So those are all good options, and very generically, we could sort of address all of these with that kind of interface. So what's great about coroutines and flow, if we want to sort of upgrade the idea a little bit, is that we can be very generic, yes, when we build repositories, but we still get some fancy behaviors, right? So here, structured concurrency means that we let the caller cancel as needed the calls to the repository, and that the caller is going to be responsible for catching exceptions and figuring out error handling, which is not per se a bad thing. It's kind of interesting to think that independently of am I running on the web or on Android or even potentially on the back end, this repo interface works everywhere. Oh. All right, so that's a pretty big win for reusability, but we are throwing a lot of metaphorical work over the fence to a view model in that kind of situation if we're back on the phone, right? Our repository is nice and reusable, but if the view model is responsible for canceling things and handling retries and all of that, then it's got a lot of responsibilities, and there's nothing wrong with that per se. But the problem is, as you probably know, the view model is a very Android-specific construct, right? So structuring things this way, we lose the potential benefit of sharing what should be pretty common behavior across the whole platform. So if we start thinking about user experience with this, we have an edit view with a lot of fields, right? And when the model needs to keep the product information in memory, it will be given view events that it will receive. It will change the in-memory copy that it has of the product variant. And at some point, our user on the form will press save, which is where the view model is going to say, OK, cool, I'm taking my memory copy, I'm passing that over to the repository. Job done, we're saved, everything is fine. So once we have that on Android and you implement it, your typical setup will see you with something like this, right? So you have your view model that sits between the view and the repository. We have a unidirectional data flow. We kind of have two of them if you think about it, but we have unidirectional data flow. The view events are consumed by view model. View state is consumed by the view. The view model and the repository are also chained, right? And the thing that's kind of interesting to me on that, and we don't often think about this, is that the timing is kind of bizarre if you think about it a little bit. Because if we're sort of looking at the view model with like a glance at how could we extract multi-platform value out of something that's Android-based, then we sort of need to start thinking a little bit, sit back and think about what kind of timings do we have with these kind of interfaces. So the reads, they occur when the view model initializes itself, right, at the very beginning when it's created as part of something in the Android lifecycle. The view will be notified that the view model is loading when it's subscribed, so it can put a spinner up if it's taking a long time to get the data. Results come back, the state is done. And then we enter a phase where the view sends, sorry about that, there we go, where the view sends different events that are modifying that copy in memory. Eventually there's a save button being pressed, and only then does the view model start re-interacting with the repo. And then we have success, hopefully, and things are good. So yeah, view model is very Android specific. And as we've talked about, in our inventory problem, form filling on mobile, that's cool, but really, we're not going to do the bulk of that on the mobile phone, right? It doesn't make sense. If you're like, you have 1,000 or 2,000 records, you start entering the data, that just doesn't scale. And it wouldn't scale for anything that looks like a store. So realistically, if to get anywhere, we need to move the manual data entry from the mobile phone and move it onto something like the desktop. So the time-consuming part of entering that data will make a whole lot more sense in a web app in this case. So that's sort of the justification to say, well, the web app is going to be the same kind of view model logic that we saw earlier, right? You're going to get view events, you're going to want to save into the repository, you're going to want to do all this work. So how do we extract sort of, like, how do we make sure that we build that logic in a way that we can reuse anywhere and connect to view models as we need or not? Right, so my personal approach has been sort of very lightweight. It's been to say, I'm creating these models. Like historically in my own code, I've always called them models. Preparing this talk, I realized that was kind of probably very misleading. I've often had discussions with with colleagues about this when they looked at my code. They're like, I get your idea of a model, but really, your model's not like pure business logic, is it? And I was always like, yeah, that's true. I mean, at the end of the day, we're talking about form filling, so that's really a view type concern, even if you're trying to make it agnostic from a view. Like, how do you think about that thing? You need to sort of, words are hard, naming is harder. I mean, what do you do with this? So basically, I've sort of settled on the idea that for at least today, we're going to call them UX models, which is not like a great news for anybody here. I'm guessing you're probably thinking, I don't want to have to deal with view models and UX models and what have you. That's just terrible, right? True, but we'll think about this a little bit more. So with this approach, what's interesting with the UX model or the middle layer model, however you want to name them, this approach, what's interesting is that for me personally, the Android view model, and I'm going to say something that's a bit heretical here, it usually is not something I add to my apps all that much. And there's some reasoning there, and well, the fact that I am a bit more cross-platform in my approach kind of justifies that, but I just want to sell the idea, or at least cause people to pause and think about what they use a view model for and when it's actually really useful, and when you could maybe get away with using something else. So here in this little diagram, I'm trying to sort of express that. We have a view on Android or a view on web, right? And let's imagine that they're both talking to this badly named model concept, which also has a product variant in memory, which also gets these signals, and that copy in memory is modified, eventually goes to a repo and it saves. So you could see that, there's probably a way of sharding away the logic that we have in our typical view models away from Android and reuse it all over the place, right? Because the same pattern applies on mostly all the types of UXs that you could think of. At least for form filling, we're always going to be talking about, I have something I'm working on and I want to save my work at some point, right? So that's a very naive approach. So if we go a bit further with that thinking, right, the problem why this is naive is that if I hit reload on the browser, or if I just rotate my phone, potentially, everything goes away, right? Like, of course, that's why we need view models on Android, and that's why there's like this lifecycle concept that we need to think of. Something needs to be saved somewhere. That's important. You can mitigate this kind of problem on Android, which is something I've done and also have gotten into, not heated arguments, but at least some debates with colleagues. I tend to move my badly named model, what have you, into the application space. That's often a bit scary to people because they're like, well, what about memory leaks? And typically I'm like, well, a form is actually fairly simple. And as you'll see, I have an approach where if you have this sort of document-based approach, you can pretty easily write a model that, it would be surprising if it ever ended up consuming any type of memory with closed documents. So you can write constructs that are not Android specific, that operate in a performant way, and that are not subjected to most of the vagaries of the lifecycle. So that's an interesting thing. But regardless, there's still problems with that idea. Like if maybe you can dismiss the fact that somebody hitting reload on a web page would be surprised that their form is empty. Sometimes I feel like people have this impression that if you hit reload on a web page, it sort of clears, that's kind of normal, but that's suboptimal, right? That's not like professional UX level stuff. If somebody's working, especially let's imagine the catalog of records, right? I sort of gave you an inkling of how much data you can sort of enter about like a given record. If you start thinking about, I got track listings, I got the list of the artists that worked on each track, if I'm starting to track all that data seriously, and then somebody typed half of that or is modifying things in there, if I hit reload or if there's any kind of possibility that I'm going to lose my work, I'm going to have some pretty angry users on my hand, right? So the solution to that is to sort of say, okay, I need an agnostic system to do a bit like the lifecycle on Android gives me, right? The view model lifecycle with saved state on lifecycle changes and all of that. I need something that works well and that I can write once and will work on everything, potentially, desktop, what have you. But in my case, web and Android was sufficient sort of reason to build something like this. And what I found is that typically, depending on the libraries you use, it's very easy to get away with that. I mean, to write your own persistence layer to keep your UX state saved. And I think I'm not alone in this, honestly. I've heard other heretics like me that have taken this approach and I got good mileage out of it. So in this specific case, you can already see from the diagram, the only difference really is that I have a sort of a third-party serializing system on the local data. So if it's Android, it could be SQLite, not the most sophisticated pick, but just for argument's sake. On the web, we have local storage. That's fairly simple to use, very trivial interfaces. And if we wanted to, we could sort of offhand to like a third-party, more commercial type solution like Firebase that works on both platforms. Firebase having the added bonus that if you want to do something really fancy, you could potentially open a document, open a form, edit it, and then pick it back up on the web if you're serializing to the cloud, the state of the actual editing. Right. I keep, sorry for the little noise there, I keep rubbing my face against the microphone. I'll try to drill myself not to do that. Right, so here's another concept that I want to sort of talk about that I've been using a lot in my sort of cross-platform journey. I'm going to look at the time here. It's always what you think, right? I looked at this presentation, I sort of rehearsed it, and I was supposed to be done by now. I'm halfway through. I'll speed it up a little bit. But here, one of the concepts I like to share with a lot of folks, and I wanted to share today, and I found a lot of great use out of, is the sort of concept of the editor. So the editor model, it's a bit pretty much what I've been talking about, this sort of idea that you can have your own non-view model type approach. But the approach I like that I don't often see used is this idea of creating a state machine out of something like the editor state that you see in the pseudocode right here. So to get a bit of a better feel on how that would work, and the diagram here is a bit rough, and it could actually change depending on what you want out of your state machine. But for example, you could imagine that your model goes through these different states, right? It's only allowed to go from a closed state where if you spy on the sealed class, you realize that when that model is closed, it takes almost no memory, right? It wouldn't keep a copy of a document in memory, which is not a big deal if it's just a form with little text fields, but which is super important if you're talking about something that might have binary data or bigger blobs in there, like something I've actually seen in production apps at a big e-commerce merchant that will remain nameless. You can end up with multiple screens that hold up a lot of space, so it's important, especially if you're saying something heretical like me where you want to keep it in global memory space, you need to be able to control and know how much memory your stuff would take if you want to be doing that. You have to be very serious about it. So with a state machine like this, it allows you to never sort of get into trouble. You can code your editor model to process intents in such a way that if it's getting intents that are out of bounds, say you're loading and somebody's trying to call for loading again to open another document, you're just going to say, no, sorry, we're busy right now. Somebody wired up those buttons wrong, view, leave me alone, right? So you can do all that sort of sanity check, and just like effectively be certain that you're not going to get into trouble. All right, so we'll fly a little bit faster here. This is sort of receiving inventory. So I'm going back a little bit to the story and getting my head out of like the pure like code world. I wanted to tell you the story of how I got half that collection. It's not a long story. A big chunk of that collection, as it happens, was found behind a building that looks somewhat like this one. This is obviously like a generated one, so it's kind of like alien landscape. But Montreal has a lot of these kind of little back alleys and things like this. So a good friend of mine sourced basically a third of our collection from a DJ store that was doing house music that closed down like in 2009. He goes to work in 2012 at some point. He walks up to the building. He works up front of the building like this. He looks next to the generator in the dumpster, and he sees like 8 little cardboard boxes, well, fairly big ones. He opens one up, and he realizes like the whole record collection was just thrown away. The liquidators decided they didn't want to bother with it. And if you looked in there, we had like single presses, like released for DJs only, like stuff that you would never find. So very, if you're into that sort of stuff, dumpster diving is like one good way of getting a whole lot of records. Problem is, obviously, that they get to your house in all sorts of various shapes and sizes and scratched in states, right? So you have effectively, all sorts of kind of records, and you need to really sift through them and decide like what's good, what's not good, And you need to do that fast, right? Like I'm talking about form filling. So we needed to think of a way to really speed up the inventory process. And the concept we fell onto was this one. So that's a bit of the rough, how we do it at home, and there's ways of getting it better. But the concept is that you have a phone, and your app can upload the images, right? And with the Bluetooth clicker, you've effectively created a one-click interface, a one-click system where you can sort of go through a ton of records, just put one up on the little stand, take a picture, next, and process it later. We know that we have great image processing tools. We'll touch on that idea in a sec, but that allows you to go through a whole lot of stuff and potentially save a ton on form filling. By putting QR codes in a frame, you can even start doing stuff like tagging the records and basically saying, this is a bad quality one, this is a good quality one. And if you improve a little bit your photo taking rig, you can start really having just flipping little switches, having little different signs next to the record as you take the picture, and start to ID a whole collection really, really quickly. So if we wanted to do this and sort of build a system for it, this is maybe one way that we could do it. The concept being that the app is capturing photo data, and in this case, it's uploading it to some bit bucket somewhere. Once you have your bucket's URL for the file that you just saved, you can hit up a microservice of your own creation or something from one of the big cloud providers to just record the entry and track progress. And then in this part of the talk, I was thinking originally of giving a quick pseudocode for the capture the photo. Nobody cares about that. First person right here up front. Same thing for the pseudocode for uploading to a bucket, like let's say we were using Firebase or whatever. Samples are all out there. What's the point of even looking at that? So we're just going to skip ahead to more like the theoretical side of things and talk about microservices. So if you know the reference, this is an interesting video on how microservices are both great and terrible. And if you follow up the little QR code I have on the flyers, you'll have the code slides and you'll have the link to the full source of everything I have here and the different references that I didn't bother talking about during this talk. But anyway, microservices, what are they? Well, at the end of the day, they're just like REST endpoints, really, and we usually talk more about microservices from the back-end point of view of how do you divide your workloads, how do you make sure you don't overload the things, how do you make sure everything is scalable. But for the app we're building now, that's not really why I picked microservices. I picked the system here called Micronaut to just build my own prototypes. I thought I'd mention it today because I felt like it was actually very easy to use and simple, and pretty powerful too. Again, I don't want to get into too much details, so I'll give you a second to take a snapshot of this if you're curious. I'm linking to 2 articles by, it's like a coincidence, 2 good friends. but their names popped up first in Google when I was looking for material on both Micronauts to build little microservices using Kotlin, and Mohit, who's having a talk right this second about Compose in another room, wrote that. Great little article. And another really interesting one is the SQLite article by Ryan Harder, where he touches on using SQLite on the back end, right? So that's a very interesting thing, especially for somebody like me who used to do SQL in the 2000s and even the 90s and found it very painful. Looking at Ryan's article, I was like, oh my gosh, this is nice. You can even get streaming queries now. That's so crazy on the back end. So for our application right now, how is that useful? Well, we can imagine, well, first I just wanted to show how easy it is to build endpoints with Micronauts, and this is what the boilerplate looks like. Nothing really magical here. You have your typical REST endpoints and how they're supposed to be used typically. I have a little monocle person here for the post, because, yeah, I find it a kind of REST breaking if you don't have in the URL the ID of the thing you're trying to update. But anyway, I'm just in the weeds right now. Apologies for that. The next thing I'm going to touch on it quickly because we're already sort of close on time. But it's something that you need to think about when you move from Android land to the back end. And isolation levels are something I think everybody's seen in school and probably promptly forgot if you're anything like me. But the thing that you want to sort of remember is that on Android, especially nowadays, we're used to this sort of streaming API mode where everything goes through this nice model or state machine or state flow. And then all the processing we're doing on this immutable state of sorts is through a single thread, right? So we're super protected about any kind of shenanigans we can run into. But if you're talking about a backend, I mean, the idea is that a backend with a database is effectively trying to give access to mutable state to as many people as it can at one time, right? So you sort of need to go back to this thinking of, oh yeah, shared mutable state is sort of a thing. But at the same time, if you remember that your top-level isolation category serialize is in play, and you make sure that you use that if you're using SQL on the back end, then you can be certain that transactions would at the very least be aborted if they're running into one another, right? And then you're getting back into this concept that we're sort of used to as front-end developers, that if you have two transactions running at the same time, then one of them will fail and you'll try it again, or well, I should say we're not used to necessarily the failing aspect of things, but it's easy enough to deal as a concept, right? It's not like rocket science or anything. Let's see. Yeah, right here, well, since we're sort of short on time, I'm going to skip through these a bit quick, but conceptually going back to this idea of using the photos to scan an inventory, because it is interesting from looking from a point of view of using back-end services from different providers. In the case of entering all those records, the conceit I had is that if we have two types of image recognition services running on the photos that we're taking of our albums, the first one will give us all the text that it can find on an album cover, potentially giving us search terms that we could use later on when we're back on the desktop. Or it could straight up match on the cover of the album and sort of say, oh, this is Paul's Boutique by the Beastie Boys from this and that year, right? So that's conceptually what we're aiming to do with the concept. And it's actually not that hard. If you just look up these two services, there's the image extract text that's available on GCP. Every single platform, Azure, AWS, they all have their equivalents. And there's that, and there's also the reverse image search with Vertex AI. That one, like a lot of other image searches, is slightly more complicated in the sense that if you're thinking of it for our use case, if I have 1,000 records and we want to match, I need a database of identified records with a photo so that I can actually look it up and try to look it up somehow and find it. So that's a bit more tricky, but I'll mention where you could get that done if you wanted to. Let's see, where are we here? Right. Yeah, I was getting back quickly to the, I was a bit rushed for this slide, does it show? So this idea here is that once you have done this image search lookup and have your meta tags, you'd be back on your web page. You'd have a list of all the incoming works that you would want. And again, we're still using the same kind of repo APIs and the models that we had on Android, and we can reuse them on the web is really what I wanted to sort of point out here. But the interesting bit, and just to complete the example of the story, is that when you hit lookup, you can then take all the metadata that you've extracted from the services and do a search lookup with one of the more classic databases. And the one I wanted to mention, if you're actually interested in the problem space, which is not technically what the talk is about, but regardless, there's this really nice online database called Discogs. My presentation software chopped off the header, but discogs.org, and they have a public REST API that you can hit up to find out about almost every releases of albums known to man. So that's a really nice place to look if you're into collecting music. And also, if you win one of those little albums, you can look up how much they're worth. I actually did not, so there's potentially some gems in there, although I doubt it. All right, orders and payments. Well, we'll wind up down the story. We're like at the 39-minute mark, which is, I suspected we'd be there a little bit. Orders and payments, fairly simple. Like, how do you track orders and process payments? You use the big guns, the big people, the big boys, the big platforms, the big girls. I don't know. I don't want to be sexist here at all. The big providers, the incumbents. That's the proper term for it. So this is, again, chopped off. This is Square's API pages. I intend to use Square personally for point-of-sale support. That's just like personal choice. And again, the logo's chopped off. Shopify, inventory levels. The reason I'm showing the API screens is that we've built an API system, and the point I wanted to make is that as for a lot of the big services that you can find out there, the way you can integrate little homebrew solutions like the one we just looked at is by using, in their case, the inventory APIs that you can find on both platforms, which are actually remarkably similar. The concepts, the ways that the databases are split, you know, it's pretty close because there's not 1,000 ways of solving these problems. And now that we know how to build microservices and our own backends in Kotlin, we can use these APIs to connect and run potentially like nightly jobs or even as-you-go type of jobs that will connect to these APIs, update the inventory levels for different types of inventories. And if you remember at the beginning, I was talking about locations. Another interesting thing is that if you want to manage a multi-platform type of e-commerce store, what you can do is say, this is the level of stock I have for my point-of-sale Square shop, and these are the levels of stock I have for my e-commerce online Shopify shop, and these are the level of inventory I'm keeping in my house because I like those records or something. So you can sort of play around with that, and that's how you integrate with the big players. And that's it for today. Thank you for your patience.